All right, everyone, welcome back. In this video, we'll be talking about something called short circuit evaluation. And then we'll look at if statements with multiple alternatives. That'll lead us into coding something called tornadoes or hurricanes, depending on your choice. In some cases, it's possible to know the outcome of a Boolean expression involving and not logical operators without evaluating both sides. So just a couple of days ago, a couple of videos ago, we learned about the and logical operator and the or logical operator. With these operators, both sides are going to be true or false values, and then the actual operator itself produces a true or false value. Okay, recall that both sides of the and logical operator must evaluate to true in order for the expression as a whole to evaluate to true. We looked at some truth tables, and the only time that and produces a true value is if both sides are true. So the moment that you have a false value, it doesn't matter what the other side is. You know the outcome of the and logical operator. If the left-hand side of the and logical operator is false, there is literally no reason to even check the right-hand side of the operator. You already know the outcome. The outcome of this and is false. Likewise, or will evaluate to true as long as one of the sides evaluates to true. We looked at a truth table for or. The only time we get a false value is if both sides are false. What that means is the moment that you have a true on one side, you already know the outcome. Okay? If the left-hand side of the or logical operator is true, there's no reason to check the right-hand side because you already know the outcome of the expression. Java, and as far as I know, every high-level programming language, implements short-circuit evaluation in order to increase efficiency by reducing operations. Programmers can actually use this to write code that would otherwise generate an error. So let me just tell you the point of this is looking at this from left to right, which is how short circuit evaluation ends up kicking in. I see a true value and an or. I don't even care what the right hand side is. I'm not even going to look at it. Okay? One thing to keep in mind is the right hand side could be an expression, something that needs to be processed or evaluated. In this case, there's some division going on, and then that division, the result, gets checked using a relational operator. Okay? This code in particular would produce an error in the event that x is 0. The division on the right-hand side of the and logical operator could potentially generate an arithmetic exception due to division by 0. However, division by 0 will never occur thanks to the left-hand side of the and logical operator, which ensures that x is not 0. Okay, I'm going to demonstrate this one, and in the process, prove to you that short circuit evaluation is used in Java. Here we go. I've got just a little test class inside of IntelliJ, and I'm basically going to recreate the stuff that we got here. We got a couple of integers. Okay. And our expression here, I'm going to copy and paste it like a G. Something like this. If this is true, we're going to print off it was true. Otherwise, or out here, we'll print off generic statement. All right. So here's the thing. X is a 0, right? So when we get to this if statement, we're going to ask, is 0 not equal to 0? Well, that's false. We have false and something. It doesn't even matter what this right-hand side is. It's not even going to be evaluated. And that's a good thing, because if it were to be evaluated, right, we would have 7 divided by 0, and you can't divide by 0. This would throw an arithmetic exception. Your program would break and stop running. So I'm going to right-click in free space and tell this thing to run. And we're going to see that this statement is not going to execute, right, because ultimately this is false. I have false and something. It doesn't even matter what this something is. The outcome of this and logical operator is already known. It's false. We have an if statement with false, which means we will skip over the body. And the only thing that gets printed is this generic statement. Okay? What I'm trying to prove to you is that short circuit evaluation works. That is, we're going to check this left-hand side, In the event that it's false, I'm not even going to execute the right-hand side. What you have to understand is, if we were to even attempt to figure out what this is, it would get an arithmetic exception. And the way that I can prove this is I can flip the order here. Okay, I flipped the order here on the expression. IntelliJ is trying to warn me. And I'm going to run the program again. And you see we get the arithmetic exception, division by 0. Right here, we encounter our if statement. We have 7 divided by 0. You can't divide by 0. The program breaks. So, with short circuit evaluation, not only is it saving time and efficiency, but you can actually use it to your advantage when programming these things. There's 2 scenarios where it occurs. With the AND logical operator, if we have false and, you already know the outcome. The other scenario is with the OR logical operator, and that is when you have true or something. It doesn't even matter what this something is, I already know the outcome. That's short circuit evaluation. Let's take a look at if statements with multiple alternatives. So in the past, we've written if statements with 0 alternatives, right? The original if statement that we learned, there's just the if and nothing else. We've also written if statements with 1 alternative, right? If this, then this. This is good in scenarios where you only have 2 possible outcomes. It's either this or this. In Java, it's possible to write if statements with several or multiple alternatives. Here's kind of the syntax of this, and I've left off braces to kind of condense this. We've noted that there's only 1 statement in each of these bodies, which is why we can omit the braces. But here we go. We have if some condition, we'll do this. Otherwise, we'll check another condition and then maybe do this. Otherwise, we'll check this condition. If all of these fail, we hit this else, and we would execute the one at the bottom. Let's walk through some examples. Here I have some fan speed setting. Don't quite know yet. And then we have a string of fan speed that we're going to actually give it a value, something like low, medium, high, or off, right? If the setting is exactly 1, I'm going to set my fan speed to low. If the setting is 2, we'll go to medium. If the setting is 3, we'll go to high. Otherwise, we'll go to off. When working with an if statement with multiple alternatives, the condition in each header is checked in the order in which they occur. Once one of the conditions evaluates to true, the corresponding body is executed and the remaining conditions or bodies are skipped. This is what's important. This is what's different. We could emulate this based on what we know already, right? With if statements and logical operators, you could simulate this. The biggest difference is, and I'm going to harp on this, and we'll see it again in the slides in just a moment, is once one of these conditions is true, we skip everything else, right? Once one of the conditions is true, we execute the corresponding body and then skip everything else. And that's going to improve our efficiency. Once one of the conditions evaluates to true, the corresponding body is executed and the remaining conditions / bodies are skipped. Okay, let's take a look at an example. Let's give a setting here, 2. All right, I'm going to say, is 2 equal to 1? Well, that's false, so I would skip over this. We're going to continue on. We would ask, is 2 equal to 2? That's true. So I'm going to set fan speed, the string, to medium and skip everything else. I don't even check this condition. I skip over the else, right? Everything else is ignored once one of the conditions is true. If our setting is 1, right, we're going to come in here, we'll say, is 1 equal to 1? Well, yeah, I'll set my fan speed to low and I skip everything else. This is where your efficiency kicks in. I'm not even going to look at these conditions. If our fan speed setting is 0, I would ask, is 0 equal to 1? Well, no, I would skip that body. Is 0 equal to 2? False. I would skip that body. Is 0 equal to 3? That's false. I'd skip that. We'd ultimately hit this else, where we would set it to off. Notice there's no condition here on the final else. That happens if all else fails. Using multiple alternatives has a distinct advantage over using multiple if statements. If an if statement with multiple alternatives provides more control and greater efficiency, right? This is the alternative. Again, we could simulate or emulate our if statement with multiple alternatives using just normal if statements and logical operators. right? We technically did that with satisfaction scale. The difference is all of these if statements are independent. They're going to be checked no matter what, right? In our example where we had like a fan speed setting of 1, right? We would check it, see that it's a 1, set the corresponding fan speed string, but we would then continue to ask, is the fan speed setting 2? Is it 3? Well, I've already determined what it is. These would be checked inefficiently, needlessly, unnecessarily. Over here on the right-hand side, however, using an if statement with multiple alternatives, once one of them is true, we skip the rest, and that is the big deal. I'd like you to also notice over here, in this example, I don't have a final else, and that's okay. You can do that. Okay, note that the last else is optional, right? Here I'm kind of showing that you could end with a final else if, and so it is possible to create an if statement with multiple alternatives in which there isn't an else clause, but you can have it. If you do have it, it needs to be the last statement. If I just throw an else in here somewhere else, it'll kind of create an if-else statement and end the logic tree, the if statement with multiple alternatives. So the else is effectively the last thing that occurs. If an else is used, it must occur last, and it must be our last in our logic branch. If a logic branch doesn't contain an else, it's possible that none of the bodies will be executed, right? It's possible. I got 3 different conditions here. It's possible that this one's false, and this one's false, and this one's false. Okay. The only reason why I really kind of bring this up is if you have like a variable that you're trying to initialize, right? Imagine our fan speed setting thing. Let's just go back to that. Right? Imagine I don't have this else down here. This final else is just gone. Okay. What does that look like? Well, is 0 equal to 1? No, that's false. Is 0 equal to 2? No, that's false. Is 0 equal to 3? That's false. What would end up happening is at the very end, my fan speed doesn't have a value. It hasn't been initialized. That's only a problem if we try to do something like print it. If I tried to access it or use it, it doesn't have a value. That is something to be careful about. Right? If you don't have an else, it's possible that no value is assigned to your variable. Okay, with that in mind, let's code tornadoes. Write a program tornadoes that prompts the user to enter the speed of a tornado and prints the corresponding tornado category. Here are our tornado categories. And I'm going to pull this over to my other screen. I'm in IntelliJ. I'm going to make a new project by going to File, New Project. I personally need to switch folders, so I'm going to go back to Principles, and we're going to call this one Tornadoes. I'm going to ensure that there is a subfolder. I'm going to expand my project folder, right-click on the SRC, make a new Java class called Tornadoes. I'm going to plug in a main method with PSVM, and we're going to quickly implement scanner. I went so fast I didn't give IntelliSense a chance to detect my scanner. That's okay. You can hover over this, hit Alt-Enter, and our first option is to import the class. I believe there's also, if we take a look, you could do Alt-Shift-Enter. I never do this one, but let's try it, which will immediately choose basically the first option that was from that drop-down menu. So we got step 1, we've imported. Got step 2, we've created our scanner object. I'm going to prompt the user. How fast are their tornado speeds? Okay, next question is, do we want an int? Do we want a double? My scale is an int, but I really don't see why we can't just use a double. I'm going to create a double called speed for my wind speed. Using my scanner, we'll capture the next double. Okay. So I have gotten the speed from the user. We're ready to start processing it, if you will. The top end of my scale, you could go either way, right? We could consider the low end, we could consider the high end. I'm going to maybe start here with the EF5. You know what? There's an argument that it's more efficient to start at the low end of the scale. The reason being is, what wind speeds are you most likely to find? Right? The chance of having an EF5 is pretty high. So why don't we do this? Let's start at the low end. If I effectively need this range, right? 65 to 85. So why don't we leave that as a comment? If my wind speed is greater than 65 or equal to, and my wind speed is less than or equal to 85, well, that is going to be a category 1. Okay? We could use several system.out.print lines right here, but I've kind of talked about in the past, while using like lots of SOPs, you ultimately get duplicate code. What I really want is just one final output statement. So what I'm going to do instead is use an integer to track my category. Right? What category hurricane is this? Or tornado, I should say. We'll go ahead and initialize. Let's not initialize it. Let's play with that and see what ends up happening. So I'm going to create a category. Right? If this is true, I'm going to have a category 0 hurricane. Instead of doing a system.out.print line, right, what I'm going to do is at the very end do a system.out.print line, and we just make one final statement. And the reason you want to do that is that if it makes it easier to edit. If we do system.out.print lines in each of these if statements, I need to maintain each of those. If I come in and decide I want to make a change, maybe my grammar isn't that great and I need to update it, then you got to update all of them. And that's not great. So all I want to do is create this integer to track my category, because that's really all the if statements are determining. Okay? So if this is true, I'm going to set my category to 0. Okay? The next category, we're going to have wind speeds in the range of 86 to 110. So I'm going to say else if our speed is greater than or equal to 86 and the speed is less than or equal to 110. That range is 86 to 110. If this is true, our category is going to be 1. Now, why don't we try out what we got just so far? Just see what we got going on so far. I'm going to do a system.out.print line and say that right there is a category plus tack on our category tornado. Let's try it out. I'm going to right click in free space, tell it to run. IntelliJ's already upset. What's going on here? It says our variable category might not have been initialized. This is what I was talking about with the variable, right? Notice that it has no value. I've declared category. It exists in the body of the main method. Its scope ends down here. What that means is its scope overlaps into these if and else if statements. Okay, the problem is if this is false and this is false, category doesn't have a value. Okay, there's a couple of ways to handle this. One, we can include our else, right? I'm going to put this through the series of tests, and if all of these fail, the else condition is basically we got an EF5. We got something with over 200 speeds. Or really, right, we don't even have a category 0. Right? this EF0 has got to be at least 65 miles an hour, right? If we enter something that's less than 65, we don't even have anything. So that's kind of a bit of a problem. So it's, why don't we do a -1? I'm going to initialize this to a -1. 0 is already a category. So in the event that like all of these fail, I need a placeholder value to indicate that it's not even a hurricane. So I'm going to put it through this gauntlet, right? If it's in this range, we got a 0. If it's in this range, we got a 1. If all else fails, I'm going to assume that it's a category EF5. And I'm going to designate this with a comment, right? That it is, what, greater than 200. Okay, so I actually fixed it in 2 ways. If we just got rid of this else, you notice that it at least has a value, right? No matter what, it's going to have a value. If you do have an else, that would also, in theory, fix it. Now, because you're guaranteed to have something. If this is false and this is false, you're at least going to execute this, and this particular statement actually gives it a value. Java IntelliJ can see that, and so it knows you are guaranteed to have a value by the time you get down here. Now, the problem with my particular program here is that this isn't necessarily true. What I'm assuming is if it's not a category 0 or a category 1 or 2, 3, 4, it's guaranteed to be a 5, but there's actually a subcategory, if you will, where we have speeds that are less than that. So what I'm going to do is include a -1 here. And the idea is, after this is all over, after this is all said and done, right, if I still got a -1 here, that means it's not even 65 miles an hour. So why don't we do one final statement, if statement. If our category is equal to a -1, well, that means we don't have a hurricane at all. So I'm going to actually change my print message. That ain't even a, sorry, I said hurricane, tornado. Otherwise, if category is any other value, that means we managed to detect a tornado. We have wind speeds that are at least 65 miles an hour. Okay, why don't we try what we got so far? I'm jumping around because I'm editing it like mid-run. Normally I do the other way, or we do hurricanes or something. How fast are then our tornado speeds? Let's say 65. That is a category 0 tornado, and you could even do this EF-0 if you wanted to, right? EF-0. So if I hit the 65, if I do 85, it's good to test your ranges, right? We're still in that range. We can take a double. Right, so if I do 86.5 for 4, that's an EF1. I'm going to go over this 110 and do like 111. And it's ultimately going to give us a category 5, which is incorrect at the moment, but let's take a look at what's happening. Right, the user enters 111. Our category starts out at -1. We're going to ask, is 111 greater than or equal to 65? It is. Is 111 less than 85? It's not. So I got true and false. This will produce a false value. We'll skip this body. I'm on to the next one. We'll ask, is 111 greater than or equal to 86? It is. Is 111 less than or equal to 110? That's false. I got true and false. We'll skip over this body. I hit this else, which doesn't have a condition, and so we just automatically do this. We set our category to 5. At the end, I'm going to ask, is 5 equal to -1? It's not, so we go down to our else, and so we say that right there is a category EF5 tornado. Okay. Let's keep adding to this. Let's fill out the rest of this logic tree. But before I do that, here's one thing I'd like you to recognize. This is kind of unnecessary. What do I mean? I'm going to check to see, is our speed greater than or equal to 65? Right? If that's true, and this is false, I'm going to continue on. If I reach this point right here, then I know my speeds are at least 65. So I don't even have to check this other end. Let me think about that before I even... Let's try this out. If our speed is greater than or equal to 65, once I hit this statement, I've already checked that. In order for me to be here, this had to have been... I already know that it's at least that. I don't know. I don't know, but this -1 doesn't sound right. Let's try it. I'm going to try to get like a category 0 hurricane or tornado, and I'm going to try to get a category 1 tornado. If I got 65, we got an EF0. Yep. If I've got an 85, well, that should be a category 0. If I have 86, all right, yeah, that's triggering. So I do need the other end of this. Yeah, the structure of this is a little odd. Okay, let's continue on. Now, it's still going to be efficient for us to use this. Our next category is 111 to 135. And if that happens, our category is going to be a 2. Else if our speed is greater than or equal to, what, 136, and our speed is less than or equal to 165, our category is a 3. Lastly, if our speed is greater than or equal to 166 and speed is less than or equal to 200, our category is a 4. This else may have to change as well. Have I tested the lower end? Oh yeah. Yeah, this else has to be an else if. Here's where things are going wrong. In the past, I've done like hurricanes sometimes as opposed to tornadoes, and 0 isn't in the hurricane scale, right? Me trying to compensate for some speeds that are less than 64. In the case of a hurricane, I can start category at 0, and if it's not, at least 65, it's not even like a category. And so that's throwing me off here a little bit with our scale, but that's okay. This is still efficient compared to the alternatives. Oh, this is just speed is greater than or equal to 200. Let's take a look. I'm going to try it for some of these, and you want to consider test cases. What I mean by test cases, they're numbers that test your program. These edge numbers are going to be really good numbers to test. How fast are then their tornado speeds? Let's go 135. That's an EF2, that is correct. Let's go 136. And it's going to give us an EF3. These are the type of things I would test out. How fast are then their tornado speeds? Let's go 165, and I'm going to kind of explain the flow of the program. Right, the user entered 165. So we grab that, that's in our speed. The category starts out at -1. We're going to ask, is 165 greater than or equal to 65? That's true. Is 165 less than or equal to 85? That's false. I have true and false. The overall is false. We'll skip over this body. We're here now. We're going to ask, is 165 greater than or equal to 86? It is. I need to check the right-hand side. Is 165 less than 110? That's false. This whole thing is false. We skip over this body. We'll ask, is 165 greater than 111? It is. Is 165 less than 135? It is not. We skip. Is 165 greater than or equal to 136? It is. Is 165 less than or equal to 165? It is. I have true and true. We will enter the body of this if statement. We would set our category to 3. And what's new and different compared to what we've been doing is that we would then skip these guys, making it more efficient, right? I'm not even going to check these things. Let's do another one. Let's do something like 86. Okay, I'm going to ask, is 86 greater than or equal to 65? It is. Is 86 less than or equal to 85? It is not. We'll ask, is 86 greater than or equal to 86? It is. We would ask, is 86 less than or equal to 110? It is. I have true and true. So we set our category to 1, skipping everything else. If these were just if statements, and I did the exact same thing, program's going to work. We got these number ranges to ensure that it'll work, right? We get an if one, that is correct. But here's what's different. We would ask, is 86 greater than 65? Yes. Is 86 less than 85? No. Is 86 greater than or equal to 86? Yes. Is 86 less than or equal to 110? Yes. I've already determined my category, but I'm going to keep going. Is 86 greater than or equal to 111? No. Is 80, and that's actually false. I got false and something, so I wouldn't even check the right-hand side. I got another if statement. Is 86 greater than or equal to 136? No, that's false and something. We wouldn't even check this side, but I am checking all of these if statements as a result, and it's crushing the efficiency. Okay, so that is probably the biggest advantage to our if statement with multiple alternatives, is that we increase efficiency. I'm going to throw in our comment here, and we're going to wrap that up. This one has been Tornadoes. See you in the next one.